Hello everyone. Thank you all for joining us for today's webinar on deploying AI with AWS machine learning and IoT services on Jetson Nano. Deploying AI at the edge at scale requires a high-performance edge compute platform such as NVIDIA Jetson and integration with cloud services for monitoring and maintaining the devices, as well as for continuous training and deployment of new models. To enable this, we have partnered with AWS to bring their IoT and ML services on Jetson. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All the widgets are resizable and movable. If you have any questions during the webcast, you can submit them through the Q&A widget. We will try to answer these at the end of the event. A copy of today's slide deck and additional help materials are available in the resources list. We encourage you to download any resource or bookmark any links that you may find useful. You can find additional answers to some common technical issues located in the help widget at the bottom of your screen. An on-demand version of the webcast will be available approximately 1 hour after the webcast and can be accessed using the same audience link that was sent to you earlier. With that, over to Mahendra from AWS team.
Hello, greetings everyone. My name is Mahendra Bairagi. I am a specialist solutions architect, artificial intelligence, and machine learning at Amazon Web Services. It's my pleasure to present a webinar on intelligent video analytics at edge with AWS AI ML, IoT services, and NVIDIA Jetson Nano. Thousands of customers are using machine learning today across virtually every industry and size of company. Automobiles, manufacturing, retail, finance, insurance, healthcare. Machine learning will impact every industry and every decision. And we are already seeing a lot of customers reinventing their business with machine learning. Our mission at AWS is to put machine learning in hands of every developer. During this session, I will walk you through end-to-end machine learning process, demonstrate how to use NVIDIA Jetson Nano with Amazon SageMaker and AWS IoT Greengrass to build machine learning at edge solution. AWS offers end-to-end machine learning platform for creating a computer vision model, starting from labeling data, training model, optimizing model, and deploying model on edge devices such as NVIDIA Jetson Nano. Once model is deployed on the edge, we offer services on edge such as IoT Greengrass to integrate the models with the rest of the AWS platform, providing further analytical capabilities. So let's look at AWS machine learning stack first. In order to put machine learning in hands of each developer, we are working relentlessly. We have more than 200 launches since 2017 in just 2 years. Most of these new services are in machine learning. AWS machine learning stack has 3 key layers. From bottom, frameworks and interfaces for machine learning practitioners, then the platform services that makes it easy for any developer to get started and get deep with machine learning, and then application services that enables developers to plug in pre-built AI functionality into their apps without having to worry about the machine learning models that power these services. NVIDIA and AWS have partnership at many levels. AWS offers NVIDIA GPU-based instances in our infrastructure layer. These instances reduce machine learning training time from days to minutes. We offer P3 instances with Tesla V100 GPUs, one of the most powerful GPU instances on cloud. AWS also offers Tesla T4-based G4 instances. This helps with machine learning acceleration and GPU-intensive applications such as 3D rendering, gaming, AR, VR. On container side, For machine learning training, AWS offers optimized deep learning specific containers from NVIDIA. This is for a cloud, and for edge, AWS IOT Greengrass integrates very well with NVIDIA Jetson devices. Now let's look at machine learning process. For many developers, machine learning is too complex. First we need to collect and prepare data, then choose algorithm, optimize it, need to set up hardware, set up environment, install libraries, then go through many iterations to train and tune. Then once you're happy with the model, you deploy the model in production or edge device. You may need to deploy model on cloud or edge. In either case, you will need to optimize, scale, and manage deployments. Also, data labeling in particular is very laborious process, especially for supervised learning models. Amazon SageMaker Ground Truth offers way to label data, but first let's see why labeling data is so painful. Well, data labeling or annotation consumes up to 80% time of machine learning projects. It's very repetitive process, needs large number of human labor hours. There is lack of tools, lack of process management, and supervised learning, the deep learning models need large data sets. With SageMaker Ground Truth, you can create labeling tasks, jobs, create your own private or public workforce, or you can also use vendors. For public workforce, you can use Amazon Mechanical Turk. You can analyze and improve labeling accuracy. During labeling, you can give more weight to data experts and lower weight to newbies, and that way you can improve the accuracy. It also offers auto labeling. So if auto labeling is turned on, it will look at labeling patterns and will try to label the next set based on the pattern learning. You can manage multiple data sets, and it offers integration with the rest of the SageMaker platform. So labeling data set can be used as is with SageMaker built-in algorithms. SageMaker Ground Truth offers different types of labeling tasks: object detection or bounding boxes, image classification, semantic segmentation, text classification, or you can build custom tasks. So with SageMaker Ground Truth, you will label data. Once you label data, you need to build and train model. You can use SageMaker built-in algorithm to build models. SageMaker offers platform to build, train, and deploy machine learning models. It helps us in the quest of putting machine learning in hands of every developer. SageMaker offers you managed Jupyter Notebook, where you can start building and sharing models with your colleagues. It offers pre-built containers. These are high-performance containers for algorithms such as prediction, forecasting, anomaly detection, image classification, object detection. You can also bring your own algorithms in containers. So once model is built, you can train model using the containers, offers you one-click training and tuning. This is managed service. Once model is trained, you can either deploy the model on cloud or use AWS IOT Greengrass to deploy it on edge devices. Just to recap, SageMaker is fully managed service. You can use SageMaker Ground Truth to label data, use SageMaker Jupyter Notebooks to build models and share the model code with your colleagues, then use SageMaker containers to train the models. AWS SageMaker offers many built-in containers such as image classification, object detection. These containers are based on leading frameworks such as MXNet and TensorFlow using NVIDIA GPUs. And if you want, you can bring your own container as well to SageMaker. There are over 16 machine learning algorithm specific containers SageMaker offers, and that list just goes on and on. We keep offering more and more containers containers for computer vision specific algorithms such as image classification and object detection are based on NVIDIA GPU instances and CUDA libraries. Once model is trained, you need to deploy model on cloud or an edge platform. Deploying model across multiple platforms is too complex. If you want to host model, you will need to install libraries specific to framework model was built on. Very often, models are not optimized for edge platform. SageMaker Neo helps with optimizing and compiling models for edge deployment. Here is a screenshot of SageMaker Neo Web Console. Shows you how to create job to optimize model for specific platform and framework. Apart from Web Console, SageMaker Neo can be used through APIs. Let's look at some of the key features of SageMaker Neo. SageMaker Neo is open source, based on few open source tools and libraries. It is compatible with NVIDIA Jetson platform. It compresses model without loss of accuracy and improves runtime performance, and supports leading machine learning frameworks such as TensorFlow, AmXNet, PyTorch. It offers console as well as API-based interface. Now you know how to label your dataset, build model, train model, optimize model using SageMaker. Next step will be to do machine learning at edge. You will need two things, device and way to deploy models on the device. For device, we will use NVIDIA Jetson Nano, and for deployment, we will use AWS IOT Greengrass. NVIDIA Jetson Nano is very affordable device, only $99, comes with a GPU, offers over 400 gigaflops performance, offers multiple camera integration such as MIPI or USB. It also has HDMI and USB ports, comes with Ubuntu, and you can run this device on USB batteries, making it portable for robotics and edge use cases. NVIDIA Jetson Nano is powered by CUDA-enabled GPU, which enables flexibility and performance for AI applications. Jetson Nano can support all popular frameworks natively and all types of models spanning from image classification, object detection, semantic segmentation, RNNs, and as shown in the chart below, Jetson Nano can offer not only flexibility but also performance that is required for many machine learning applications. Let's view this diagram from right to left. You have built the model, trained the model, optimized model. You have device Jetson Nano. To run machine learning at edge, you will need model and inference code to run model. Many machine learning use cases needs fleet management capabilities, large-scale deployment of machine learning capabilities on devices such as smart cameras, autonomous vehicles, and robots. AWS IoT Greengrass will help you deploy and run model and integrate model with rest of the AWS cloud platform. AWS IoT Greengrass extends AWS onto your devices, so your code can run locally on the data generated at edge while still taking advantage of the cloud. Greengrass is an IoT gateway you can deploy on devices. It offers IoT gateway capabilities as well as it also runs Lambda locally. With that, it extends intelligence to the edge, take local action, local triggers, local resource access, local machine learning inference. You create Lambda on a cloud and deploy locally on device running Greengrass. It offers cloud-based deployments. So once Greengrass is set up on device, you don't need to log into device again. You can deploy the models and inference code from cloud. With that, you can manage fleet of devices. It integrates with rest of the AWS services securely. It also offers SDKs for more flexibility. For machine learning Inferences, it offers acceleration by using local GPU and optimizers such as SageMaker Neo runtime. Alright, let me walk you through the demo, putting all these services and features together to build machine learning application on Jetson Nano, performing intelligent video analytics.
Alright, so now is a demo time. So first of all, let's go to this GitHub, github.com, Mahendra Bairagi, and then this repository. Okay, I have laid out all the steps for this demo. There is not enough time for me to go through all these steps in the webinar recording. So for first the step, at least, you will need to do this by your own, but it's very easy, very self-explanatory. So what these steps are, the first step is to annotate the data. Okay, so first you are going to get your data. In this case, we have the Lego dinosaur data. So there are 6 different classes of dinosaurs, and we are going to use those different classes of dinosaurs and create an image classification model. Okay, before we create image classification model, you will need to annotate the data. So that is the step 1. So in step 1, you will need to upload the data, and I already gave the data file here. Okay, so you need to download the data file, unzip it, then create S3 bucket, then load the data back there, okay, to the S3 bucket. Once that is done, you need to go to SageMaker Ground Truth. Okay, how do we go to SageMaker Ground Truth? SageMaker AWS main console, right? Then you go to SageMaker, right? And then you go to labeling job. So that is where the ground truth is. So you saw ground truth for labeling, notebooks for building the model, then the training for training the model, and then the optimization and inferencing here. Okay, so let's go to label here. So this is what I created, this job. Okay, so what you can do is you can go create labeling job, and once you do the labeling job, you create the job like this. Okay, and in this job you need to just say where is the input file, and then where the output is going to be. Is this going to be an image classification, object detection, semantic segmentation? And then once you choose that, then you can start labeling. But before start labeling, you will need to create a workforce. So go to labeling workforce. You can send your annotation to public workforce, which is Mechanical Turk, or you can send it to the vendor, or you can create your own private workforce. You can go to private, then create private team. You can create private team, and then you can invite worker, and you can add those workers in your private team. Okay, so once you set up the job, you can go to it's going to look like this. Okay, then you go here, and this is the URL. Okay, and then you enter your user ID. Yeah. And once you sign up, you get the email to sign up for the user ID. Then you start working, right? And then this is how you annotate. So this is, I think, Stegosaurus. So I click here, do the Stegosaurus, submit, right? This is I think this is the one, Dilophosaurus. Yeah, so I submit like this. Okay, so this is the workers view, and then I'm going to log out for now. Once I log out, my job looks like this. Okay, so is going to get updated for a few more images, and this is, once all my workers are done, I will see the output in the manifest file in the output location. Okay, so that's the image annotation or the labeling the data. Once the labeling is done, you will need to train the model. Okay, so this is again very easy to set up. The ground truth is very easy to set up. Now you need to train the model. Okay, so I already gave you a notebook. So what you need to do is go to SageMaker, go to the notebook instances, create a notebook instance. Okay, just type test. You can choose one of the cheapest notebook instance because we are not training on the notebook. Okay, then you can choose the execution role. Okay, then there are a few other options. You can just keep it as is and then create notebook, and then notebook will be created like this. Okay, and then this is just a hosted Jupyter in the notebook. Now if I open it, it looks like this. So what I have done is I gave you this already created notebook file. Okay, so you use that notebook file. I also have some instructions here how to create the notebooks. Okay, then I go back here, then I say upload. When I say upload, and then I give this file that I downloaded from my Git, and then this is how it's going to look like. Okay, once I open the file, I need to follow the instructions here. Okay, so you need to come up with your own bucket name, for example, and then this SageMaker notebook shows you how to build the model. Okay, how to train the model. So this is building the model. Then this is where the manifest file from the earlier annotation job is, and then I split the data, and then I split 80-20. Okay, then I because for image classification is a deep learning algorithm, so I need to have validation and training the data. So I created validation, training. Then there are a few other parameters I need to pass. Then there are hyperparameters, epochs or epics, learning rate and things like that. Then here I choose what instance type. I am choosing P instance. These are the NVIDIA GPU instances. I can go with the P2, P3, 2 extra large, 16 extra large type instances. Okay. Then also I need to mention where the output and input data is. See, this is going to get trained in a container. So container doesn't have access to notebook. But if you tell container where to go and get the files from the S3 bucket, then it can go get the files from the S3 bucket or the data set from the S3 bucket. And once the model is trained, it will save the models back to the S3 bucket. Okay, so this is how it's going to look like. You train. Okay, and I told you this is container. So where is the container? Here. Okay, image classification. So it gets the image, and then that image, the container is called here. You pass all the parameters to container, train. Okay, once you train, so remember we talked about SageMaker Neo. SageMaker Neo helps you optimize the model. So we're going to use SageMaker Neo through SDK. Okay, so I already created a model here. It takes 10-15 minutes to create this model. There are not that many files. Once the model is created, it's going to be stored here in this location, and the model name is going to be, or the model file name is going to be model.tar.gs. Okay, then for optimization, I need to give the input model path and then output path where the optimized model will be saved. Okay, so then if you look at here, just create a compilation job, and the important things here are going to be where my model is, what the input configurations are, framework. So this image uses MXNet, so I give MXNet. If it was TensorFlow, I would have given TensorFlow, and then output platform or target device is going to be Jetson Nano. Okay, once I run this, it will compile and it will save the model in output.path file. Okay, so once that is done, then I go back here. Okay, now my model is created. Now I can go back and deploy that model on Jetson Nano. How do I deploy the model on Jetson Nano? I need to use Greengrass. Now I will show you how to set up Greengrass. Okay. So when I train my SageMaker notebook, let me show you how this looks like. Okay. So this is my notebook, and when I train it, you will see the output like this. Then it says transform, job started, is completed. So that means the training is complete. Then it shows optimize job, and then once the optimization is done, it shows optimization is complete too. I can go to SageMaker. I can see my training jobs. This is complete. I can see my compilation job, right? And it shows it's complete as well. So that is how I'm going to see my labeling, notebook instances, the job status, and compile job. Okay. So this is where we are at. So we are done with the training now. The training is the model is going to be available in S3 bucket. So I copied the model in the S3 bucket here. Now, so we are done with the first two steps. The first step was to do a labeling annotation. Step 2 was to build the model, and then step 3 is going to be deploying this model on Jetson Nano. Okay, and then where is the model file again? So once I compile, I go here, and my model file output is going to be here. Okay, and that's going to be a tar file. Okay, so this is my model file, the tar file. So I need to remember where my model file is. Alright, now what we're going to do is we're going to deploy the model on IOT Greengrass. So what that means, I need to go to the JetBot now. I need to go to JetBot. I need to install SageMaker Neo Runtime on the JetBot. Then I need to install IoT Greengrass. Then I need to the setup and configure in inference Lambda. With this is the something that I can do it on the Lambda, and then I can integrate that with IoT Greengrass. Once the Lambda is set up, I can do deployment, and then Lambda will get deployed along with the model. So I need to set up model as well. So once I set up model and Lambda, I can use that deployment and deploy it on the edge. And once the deployment is done, then I can go to IoT console and see the inferencing. Okay. So first step is I need to go to SageMaker Neo Runtime and download SageMaker Neo Runtime on my machine. So I already have finished these steps. So what I can do is I can go to the SSH. I already SSH'd to my JetBot, right? Then once you SSH to JetBot, you can either SSH to JetBot or you can just directly go to the console or desktop and log into desktop, and then you can go to this URL here. Okay, this URL shows you how to install SageMaker Neo Runtime. So the platform that we need to use is going to be Nano. Okay, so we need to download this file, and once we download this file, then we use this file to let me go back to my GitHub. Once I download this file, then I just do pip install and that file. Okay, pip install that and that file, and then I have my SageMaker Neo runtime install. With that, I don't need to install AmexNet. Okay, installing AmexNet takes a lot of time. So this model is built in AmexNet. If this model was built in TensorFlow, I need to install TensorFlow. But with SageMaker Neo, I don't need to install any of this. I just need SageMaker Neo runtime. Once that is done, I need to log in to my my device. I need to set up my IoT Greengrass. Okay, so before I do that, I need to create this user group. Okay, so this is my JetBot. I'm adding that. Okay. All right. So GGC user is created, and now I need to create a group, and I go create a group. Okay, that's it. So here I'm showing you how to log into. What I did was just SSH. Okay, and then I log in here, and I create the group. All right. Then I need to actually go to this configuration here or this document here. Alright, I logged into AWS console. So basically just go to AWS console, then look for IoT core. and then we go to IoT Greengrass. The other way you can do it is by just directly going to IoT Greengrass. Okay, so IoT Greengrass. Then you want to create first group. So let's choose easy creation. Then let's say the name of this group is going to be AWS NVIDIA webinar. Yeah, everything default. Then you're going to hit create group and core. Alright, you gotta wait for all this stuff. Then you download these resources. That's going to be a tar file, very important, right? This is a tar file. Then you also choose a CA, and then you choose a platform where you want to install. So you have to right click, and then it will show up the root CA, and then you can go here and then save the link as, then you can save. Okay, and then if you want to get additional Greengrass software, you click your platform and you can download the SDK that you need. Alright, in a few minutes it should have AWS NVIDIA webinar Greengrass group. So now my AWS Greengrass group is created on cloud. Now I need to install the actual Greengrass software on the device. So I'm going to go back to my SSH. Okay, then going to install this software. Alright, it may take a little bit, not much time. Okay, cool. Then I need to run this command to untar the Greengrass. Okay, untar. Alright, then I need to go and untar the certificates. Alright, so this is where my certificates are. So I downloaded on my machine and then I SSH'd or SCP'd over. Okay, then Greengrass. Okay, so Greengrass looks good. Alright. Oops. Greengrass. Okay. Alright. So now I got my Greengrass setup. There is one more certificate I need. Okay, and that certificate is the root certificate. So I go to search directory, and the certificate that we install, you will see those there. Now I need to get a root certificate there. So let's go get the root certificate. Alright, so now I got root certificate too. Okay, then I go one more directory back. I go to configure directory, and you will see config. Okay, so this is where all the configurations are, and this is my own the Greengrass setting that you saw in previous screens. Okay, so this is basically same as if I go back and AWS IOT core, or I can directly go to Greengrass. Greengrass is under AWS IoT core as well. Here, this is the one I created earlier. Okay, now let's go back to the Git instructions. Alright, now I want to start my Greengrass. So how do I start my Greengrass? cd Greengrass directory gzc core, yeah, and then sudo // Greengrass SSD start, and then it will start now. Alright, so Greengrass is started. Next is going to be, so Greengrass is basically the IoT gateway and this IoT gateway at edge has a capability to run Lambda code. Okay, and the Lambda code is something that we're going to use as an inference code, and then it also helps you out downloading the model too. So there are two things you need for inferencing: the model and Lambda code. And with the Greengrass, you can actually assign the model to the deployment, and you can assign a Lambda to the deployment and deploy those things from cloud. Okay. Now let's look at step 3, deploying model on Jetson Nano using AWS IoT Greengrass. So this step 3 first needs Lambda function. Okay, so we need a Lambda function as an inference function. So if you go down here, now we already have Greengrass installed now. We have SageMaker Neo installed too. Now we need to go to Lambda function. So let's follow these instructions here and go to Lambda and create inference Lambda. So I'm already providing you a inference script here. Okay, so let's go to Lambda, create new function, blueprint. We are going to use blueprint Greengrass. Okay, hello world Greengrass. Let's name inference Lambda. Okay, webinar, and then we can use existing role. Okay, it just needs the basic permissions. Then we are going to say create function, and this is going to give us really basic hello world function for Greengrass. Now we are going to replace that code with the inference Lambda code. Okay, from the GitHub. So I cut and paste. You probably saw the handler is handler, so I need to put the handler here. Okay, and then it's Python 2.7, and I'm going to save it, and I'm going to publish this version now. Okay. Alright, so the Lambda is now available. Next step is going to be setting up Greengrass. Okay, so in Greengrass we need to go to a management console. Okay, so let's go back to the management console. Greengrass, and there should be already a group here. Alright, so there is a group. Okay, so now we're going to add this Lambda that we created. I don't need this Lambda, that was just a test. Add new Lambda, use existing Lambda, and we're going to use inference Lambda webinar. Alright, that's version 1 finished. Okay, I need to add more resources to this Lambda. Okay, so this Lambda is here. Now I need to add machine learning resources. Machine learning resources, I go here, and remember we have the model saved here in this S3 bucket, so we go here. Alright, now we go back and we name it just the model. Okay, then the model source is going to be the S3. So, and this is the S3 bucket name, the dinosaur detection Neo, and this is the model file, and I need to give local path. Okay, and local path is going to be model path. Okay, then I save. Alright, with this, model is now set up. Okay, the Lambda is set up, and what else we need, and you should follow the instruction for additional help, but we need to make sure that the Greengrass core is set up correctly, so we can just go around here and check. Okay, and then for Lambda, we need to make sure the Lambda is long running Lambda. So it's not just a one-time Lambda. Okay, so what that means, I go to Lambda here and I make this Lambda. I first need to increase the memory, since this is the image classification, is going to use a lot of memory. And see here, I need to make this long running Lambda. Okay, and then I say update. Okay, so with this configuration I need to do a few more changes, but at least with this configuration I should be able to go and deploy this Lambda and the machine learning model to the Greengrass device. So this is what's going on now. So this is going to deploy, and I'm going to say automatic detection, and now my model and Lambda will be installed or deployed on the device. Once the model and Lambda deployment is successful, you will see a success message like this. Okay, once the model and Lambda deployment is successful, you will see a success message like this. Okay, then so now it means the Lambda is running on the edge, and you should be able to see the output coming from the Lambda running on the edge to cloud. So if you have the dinosaur images, or you can just take a printout of a dinosaur image and put it in front of the camera, and you should start seeing the inference. Okay, here, so you can go to IOT and then found, and in my case it may take a little time, but this is where you will see the output. Alright, so now the final step, and the final step is how to visualize and analyze video analytics from the model inference on Jetson Nano. So the instructions are here. So what I'm going to do is I'm going to follow the same instruction. Basically what we are going to do is we are going to create a CloudWatch dashboard for all the data coming from the Jetson Nano. So I'm going to go to CloudWatch. How do I go to CloudWatch? AWS Managed Console, CloudWatch. Right, in a CloudWatch I'm going to create new dashboard. So create new dashboard. So let's say Dino detection analysis. Okay, Dino. Yep. Then I'm just going to choose line. Yeah. Then you will see there are all kinds of metrics available. But if you look at our Lambda code, in Lambda code we are only sending Dino detect. Okay, so we are going to look at the Dino detect, and these are the metrics with no dimension, and then here. So these are the different types of dinosaurs detected, okay, by our code. And then our code, the Lambda code, has been sending this data back to CloudWatch. So I'm going to select all. Okay, then these are the different things you can do. We just have 1 hour data, I guess. So a few hours data. I've been testing this out for some time. So I have some data here, but what we can do is look here. I think this is unknown. This is unknown dinosaur. So a lot of unknown dinosaurs, and then we got few others here, known dinosaurs. So I'm going to create the widget. Alright, so if I enlarge it, now you can actually see the analysis, how many times the known dinosaurs were found or unknown dinosaurs were found. I had some better luck a little bit later, when I was testing this. So I see a lot of other types of dinosaurs detected here. Okay, that's it. So now you will learn the end-to-end machine learning process. Okay, so you learned how to annotate data. That was long. Okay, so you learn how to annotate data, how to build and train the data, build and train the model using annotated data. Then we also optimized the model using SageMaker Notebook. Then we deployed the model on Jetson Nano using IoT Greengrass, and then we visualized and analyzed video from the model inference. Okay, so this GitHub is going to be available for you. You can follow the same GitHub, and you can refer back to this webinar and see if we can build the same. Okay, and you can experiment more. So the dataset that I used were dinosaurs dataset. You can use any other dataset. Then I used image classification. The model, if you want to use object detection, you can use object detection, semantic segmentation as well. What we have done here is we have given you all the building blocks to do end-to-end computer vision, and we also offered you a way, or we showed you a way to visualize and analyze video analytics from Jetson Nano. So this concludes the presentation, my demo. It was a pleasure indeed to walk you through the entire step of building end-to-end computer vision along with visualization and analysis of video analytics. Thank you.
Thank you all for joining us, and now we will move into Q&A. You can submit your questions through the Q&A widget. Thank you all again for joining the webinar today. I'm going to start off by taking some of the questions that we got from the users who are watching the webinar. And you can continue to post your questions, and we'll try to answer as many as we can in the time we have. So the first question we have is about the frameworks that are supported on Jetson Nano. So since the Jetson Nano supports the full GPU that is available on all NVIDIA products, it supports all popular frameworks, whether it's PyTorch, Darknet, TensorFlow, Caffe2, all MXNet, all frameworks are supported on the Jetson Nano. There was another question about the power consumption on Jetson Nano. So Jetson Nano can be configured to consume as little as 5 watt and still performs real-time inference, deep learning inference. The third question I have here is about, is it possible to process real-time video with this configuration? Absolutely, yes. That's exactly what the Jetson Nano is designed for. And in fact, we will be very soon releasing a version of our SDK called DeepStream, where you will see a sample where you can actually process 8 video streams in real time in parallel on the Jetson Nano. So there's a lot of compute that's packed into this product. I think there are a few questions for Amazon team, and I'll let Mahendra answer those.
Thank you. So I see a few questions here. The one question was on YOLO 3. Can we train and deploy YOLO 3? We can, definitely. So on SageMaker, you can build your own container for YOLO 3, and you can train the model on YOLO 3 and then deploy using Greengrass and Lambda. If you're looking for the built-in container, then we have SSD container in SageMaker, and for general purpose object detection. So if you're looking for SSD, general purpose object detection, SageMaker already has container. For YOLO, you will need to build your own. Then I see a question on what are the possible applications that Jetson Nano and machine learning can do. So I see a lot of applications in smart cities, smart homes, smart roads, and then in specific robotics. And there is one more question. Which features or infrastructure make AWS IoT specific to the IoT application domain? So if you look at the AWS IoT Greengrass, the AWS IoT Greengrass itself is Edge Gateway, MQTT Gateway. So whatever MQTT Gateway does, most of those things can be done through IoT Greengrass. So it's an MQTT broker. So you can send messages from multiple different devices within the Greengrass group to each other, and it doesn't need to go through the internet. So without any connectivity, all communication can happen locally. And then if there is connectivity, then Greengrass can connect back to the cloud. So it offers offline connectivity. And apart from being a IoT gateway, Greengrass also runs Lambda locally. So you can configure Lambdas in cloud and then deploy on the Greengrass, and Greengrass can run Lambda. So it gives you
not just a routing processing capability, but it also gives you the capability to run the actual code on the device. Back to you, Amit. I think there are a few more questions on NVIDIA.
Yes. So there was a question on the implementation of RNN networks for Nano. The answer is absolutely yes. And I'll reiterate what I mentioned earlier. Since we have the same CUDA GPU that's available on a big Tesla Quadro or GeForce card, anything that you can do on a big GPU can be done on a Nano. So it runs the exactly same software stack. So you can run all frameworks, all kind of models, speech processing, audio, video processing, text processing, whatever you need. It can be done on the Nano.
Yeah, so it's basically a real GPU.
Right. Yeah. I think there's a question for you, Mahendra. Does AWS SageMaker use TensorRT for optimization on Nano?
So SageMaker Neo, if you look, SageMaker Neo is open source. If you look at SageMaker Neo for NVIDIA platform, it does utilize TensorRT. And then if you, I can actually paste the link to the SageMaker Neo DLR, the GitHub.
There was a question on how many nodes were used to run the learning for this particular demo. I believe it was done with single node.
Single node, because there were only 388 something like images. So that kind of images, you really, and I was using one of the powerful GPUs. So the training only took like 5 minutes on P3 instance.
There's a question about providing SD card images for Jetson board with AWS Greengrass and other requirements installed. I think that's a very good suggestion. And what we envision in the future is, as Mahendra has done, is make these available on the GitHub as a container. And we are supporting containers on Jetson. So in order to keep the size of the image small enough that we are providing the basic prerequisites and making our software modular that people can just pull in the container images, we would continue to work on making our partners like Amazon create container images that can be pulled in. So it's easy for developers to use it instead of blowing up the default image by itself.
And if I can, apart from you creating your own containers, SageMaker also has marketplace. So there is the AWS SageMaker the marketplace, and a lot of our the partners, customers, they've been building models, and they're offering those models through marketplace. So I just saw YOLO 3 being offered as part of SageMaker marketplace.
The question on how many models can be deployed simultaneously. So there is actually, from the architecture of the product, there is no limitation on how many models can be deployed simultaneously. It totally depends on the size of the model that you're going to deploy, and and the performance that you want. You can batch things up. You can in the deep stream example, we would show 2 models running, and so it's possible to run multiple models as long as you can fit it into the memory size of the product as well as the compute requirements.
And for the JetBot, JetBot, there were 2 models running at the same time. One to follow the road, other one was to detect the dinosaurs and obstacles.
So we had a classifier and a detector running in parallel for this particular example. There's a question for you, Mahendra. Where can I learn about using SageMaker models offline?
SageMaker models offline. Yeah. I mean, SageMaker documentation is all on a GitHub. So if you want to get up to speed on a SageMaker, you can go to SageMaker, and then either you can go to AWS site on a SageMaker, and there is also a very good GitHub where you can learn SageMaker. And then SageMaker, a lot of SageMaker is really based on open source. Right? So if you look at SageMaker, the notebooks are Jupyter notebooks, the containers are very standard container. A lot of those containers, especially for GPU, are based on NVIDIA container.
There's a question about whether there's a network attached storage is needed between the video camera and the Jetson Nano. As I mentioned, you could directly process the data from the CSI or the USB interface, and you don't need to do a storage. But most of our customers who are deploying this product want to keep the video footage for future, so they encode it and store the data, but you do not need to have the video coming into the storage and then feeding into the Jetson. You can directly feed it into the Jetson and have a good performance. There's a question on when is DeepStream 3 coming out on Nano. It said Q2 of 2019. So as I said earlier, we are targeting this month. You should just keep an eye on your email from our developers zone. The DeepStream support for Nano is going to be available very soon. There's a question, is it possible to use models produced or trained on digits on AWS Greengrass with Jetson Nano? Yes, absolutely. Amazon Greengrass is just an interface that provides you connectivity to the AWS console and a messaging infrastructure and authentication. So there is no restriction on the kind of machine learning models that you can use with Greengrass. And Mahendra, can you add something more?
As long as you have the runtime code.
Yes.
And then the way you can do that, deploy the model in that case is you create the model and save it on S3 bucket, and then the Greengrass can pick it up from the S3 bucket.
Exactly. I think this question was asked, can darknet be optimized and trained in SageMaker? I think this is tied to the YOLO question, so it's probably, it is available in the marketplace, but not as a default notebook in SageMaker, correct?
A notebook, a default container.
Yes.
So you can build your own container, which is really easy. You can build your own container, bring your own container, and then you can run that to the SageMaker.
How many frames of SSD can Jetson Nano process if trained with SageMaker Neo? So we have published some data on the performance for SSD. The SSD model, again, depends on what backend you're using. If we have released a sample of SSD MobileNet, which can process at about 38 frames per second on the Jetson Nano. And again, it would also depend on the resolution at which you want to process data. Mahendra, there's a question here for you. As someone who is unfamiliar with IoT Greengrass, what are the limitations of Lambda functions that can be executed on Jetson via Lambda compared to software which is running natively on the device?
So the Lambda running on Greengrass, the limitation is going to be really the container. If container can access those local resources, then the Lambda can access those local resources. So there is really no, apart from that, there is no other restriction. The container needs to have access to the local resources. So local resources can be cameras, can be shared memory. So as long as Greengrass have access to those things, the Lambda should work. The other thing is, in a Greengrass, you have to set up how much memory the Lambda needs. Okay, it's not going to use all memory, which is good. Okay, that way you can isolate the Lambda. So if you're running multiple Lambdas, you know how much memory those need. So it's just a little bit setting. So you need to know how much max memory you want your Lambda to use, and then it should be okay.
There's a question on when was the environment of Jetson configured? Does it have OpenCV installed? And I believe for the demonstration and the GitHub that we're using, it doesn't have an OpenCV installed on it.
The one that I used was Nano built. Nano comes with a SD card.
Right.
SD card has the OpenCV already.
Yeah. So the answer is yes, it does have OpenCV installed on it.
Which is good.
Yes, absolutely. There's a question on how can we deploy custom-built models, and I think Mahendra already answered. You can store your models in the S3 bucket and then deploy it through that.
So if you want to build custom model in a SageMaker, you can bring your own container. If one of our containers is not what you're looking for, and then once you train the model, within SageMaker or outside SageMaker, you can keep that model on S3 bucket, and from Greengrass, then you can download it to the device or deploy it to the device.
There's a question, can H5 model saved from Keras be deployed in SageMaker?
SageMaker doesn't deploy, right? So the Greengrass deploys.
Yeah.
Yeah.
So SageMaker again is used for training of your models, and
Greengrass is used for deploying. So you can use Keras.
Yeah.
With the SageMaker. Right. You can bring your own container. You can use one of our containers. You can train the model. You can save the model H5, and then you can deploy that model on the device. But you need to write the inference code in a Lambda that knows how to use the H5 file.
Right. Yeah. There's a question about security when using Jetson Nano. So Jetson Nano has all the advanced tools from a operating system perspective. We provide things like secure boots on a production module. So as you know, Jetson Nano comes as a developer kit as well as a production module that you can use to build products. So on the production module, if you build your own design, we support secure boot, and we have a lot of fuses that you can configure as an OEM to make your design really safe and secure. So I would encourage you to take a look at some of our documentation that we have for security, and it is designed for enterprise-class deployment. There's a question for you, Mahendra. Can we install libraries on Jetson through Lambda or Greengrass? Is there a way to do something like install into the device through the AWS console? Or would this be done with containers?
No.
I think the answer would be that you would deploy this.
I mean, it's a Python code. You can do a lot of stuff in Python code, but I will stay away from that kind of stuff. Right. So it's better you prepare the machine first and then deploy the libraries. Yeah. With the Lambda, whatever libraries you need, you can install those libraries as part of the Lambda package. So instead of you installing something through PIP or APT, you get the libraries and make that as a part of your Lambda. And when Lambda is deployed, all the libraries are deployed with Lambda. That's easier. There was one question on the Greengrass supports Python 3.6. I believe Greengrass supports Python 3.7 already, but if you're looking for something specific on Python 3.6, let us know.
All right, I think with that, we will wrap up the webinar. Thank you all again for joining us today. I hope this was useful for you. We will send you an email with the links to the recording of the webinar as well as some of the resources that might be useful. And with that, we'll end the call here. Thank you.
Thank you very much.